This is finding the zeros of the function. This first slide, I'm just going to highlight the important pieces of finding the zeros of the function. You want to have some polynomial, and you want to set it equal to 0. So if I give you a function, let's say that looks like this. F of x equals 3x squared plus 4. You want to set that function equal to 0. So you remove the f of x notation and replace it with 0. What we want to do is we want to go out and find out what the zeros of the function are. Some of the methods are factoring or solve by undoing, quadratic formula, and what these zeros represent are 4 different pieces. When you find the zero, it's called the zero of the function. It's a solution to the polynomial, it's a factor, and it's an x-intercept. That's probably one of the most important pieces for you to understand, is that when you go out and graph these zeros of the function, they are the x-intercepts. So I would say for this slide, I'm going to go ahead and erase this. Real zeros of a function, 1 through 4 is what I would write down. Go ahead and pause if you need to. The next piece is what we call a turning point. So go ahead and write this down. A turning point is when it goes from an increasing to a decreasing function, or vice versa, decreasing to an increasing. So this would be an example. If I give you a graph that looks like this. This is a snake. It has some turning points. Here's a decreasing, and then it goes to increasing. This piece right here is the turning point. And then it turns again one more time. It goes from an increasing to a decreasing. So there's the other turning point. So we have 2 turning points. This place and that place that I just circled in purple. How you can tell how many turning points you have is look at the degree, and it's 1 less than its degree. So for example, if we give you a function that looks like this, 3x to the 4th plus 2x squared plus 5. So we call this a quartic function. You look at the degree. In this case, the degree is 4. So you go 1 less than that. So you're going to have 3 turning points. So for your notes, make sure you're writing this down in its entirety. Now let's go ahead and do a problem that'll look like what's in your homework. So we give you a function, and we want you to find the zeros of the function and how many turning points it have. So our function is f of x equals x to the 4th minus x cubed minus 2x squared. Let's first identify how many zeros there can be up to. That is dependent on the degree. The degree of this function is 4. So that means you can have up to 4 zeros in the function. Then remember we just talked about the turning points. You go 1 less than the degree. So since our degree was 4, we could have up to 3 turning points. Now we're going to go ahead and find the zeros of the function. Remember the important piece of the zeros of the function, they are your x-intercepts. So we're going to set this function equal to 0 and solve for x. So 0 equals x to the 4th minus x cubed minus 2x squared. We're going to first look to see if we can solve this equation by factoring. So the number 1 rule of factoring is to factor out a GCF, greatest common factor, which you can take out an x squared. So I'm left with x squared minus x minus 2. Then I look inside of the parentheses. I can continue factoring that using the chart method. Because this is a trinomial, the leading coefficient is 1. So I have x minus 2 and x plus 1. Now what I've done is I've factored this completely. I'm going to go to step 2 and use the zero product property. I'm going to set each of the factors equal to 0 and solve for x. So I have a factor at x squared. So I'm going to set that equal to 0. I have a factor at x minus 2. So I'm going to set that equal to 0. And then I have my last factor of x plus 1. Set that equal to 0. And I solve them separately for x. So the purple one, x squared equals 0, I want to solve that for x. So I want to undo the squared, so I'm going to square root both sides. X equals plus or minus 0. There isn't a such thing as plus or minus 0, so it's just a 0. And notice there's an x squared, so I'm going to put a 0, 0 here. This is what we call a repeated 0. Now let's go on to the red one. We're going to solve that one for x. So add 2 to both sides. So there's my 0 there. And then my last one in the blue, subtract 1 from both sides. So now I have my 4 zeros. I have a repeated 0 at 0, 0. I have a 0 at 2 and a 0 at negative 1. Step 3, let's identify those x-intercepts. So I have an x-intercept at 0, 0, at 2, 0, and at negative 1, 0. Now, let's take a moment, if you have a graphing calculator, go ahead and substitute this function into your graphing calculator for, remember, f of x represents y in your graphing calculator. When you graph this function, it'll look like this. Notice, if I talk about what the shape of this is a quartic function. It opens up, it has end behavior rising on the right, rising on the left. What happens here is it's decreasing, and then it goes to increasing. So we have a turning point right here, and I'm noticing it right there. And then it goes to another decreasing, so we have another change. So a turning point here in the blue dot, and then another turning point here. As this then goes back to a increasing function.